the lesson objective. So, and the objective of the lesson is, by the end of the lesson, we should be able to solve problems involving bills. That is our objective of the day. By the end of the lesson, we should be able to solve problems involving bills. So, we are going to start by looking at some of the terms that are used in this topic, or some of the terms that are related to bills. So number one, we have the word itself, the word bill. So what is a bill? A bill is normally issued by a seller to a buyer, showing the list of items bought and their cost. So when you buy something, you're given a list of whatever you have bought and their cost. That's what we call a bill. So in this lesson, we are going to learn how to prepare these bills and how to get the cost. Then we have another term, which is balance. Balance is the difference between the amount of money given out and the total cost of the items. For example, when you buy something, maybe let's say that whatever you have bought cost 20 shillings and you have given out 10 shillings. So the person, the seller is going to give you or to refund you back 10 shillings. The 10 shillings that you're going to receive, that is what we call the balance. It is the difference between the amount of money given out and the total cost of the items. Number three, we have what we call change. Change is the exchanging of money for the same amount of money, but in different denomination. So that means it is amount equal to, but in different denomination. For example, I have 100 shillings note and I'm given maybe 5 20 shillings note. So that amount is equivalent. It's only that the denominations are different. So remember, our currency, or the money, exists in two currency or in two denominations. That is in note form and also in coin. So the moment you exchange, you get the same amount of money but in different denomination. That is what we call change. So those are some of the terms that you're going to come across as we deal with this topic, or this subtopic, bills. In this topic, we have some symbols that are used when you are calculating, or when the moment you are getting the bill. We have those symbols that are used. For example, I'm going to list them down. We have this sign. We have at, per, each, and then we have for. These are some of the symbols that we come across any moment you are getting or you are calculating the bills. So this sign here, we read it as at. This means that for you to calculate, this means this is the cost of every item. The cost of every item. At means also the same. It is the cost of every item. We have per to represent the cost of every item, and each to represent the cost of every item. For example, maybe I told that a bag of 1 kg of sugar cost 50 shillings. And then you're told that maybe someone bought 2 kgs of sugar at 50 shillings. That means, because here we have been told that 1 kg cost 50 shillings, this at here represents 1 kg of sugar at 50 shillings. So you're going to take the 2 kgs, you multiply by 50, because this 50 is the cost of 1 kg of sugar. So at this sign, at, per, each, means the cost of every item, and for you to get the total cost of all those items, you are required to multiply. Then we have another sign that they use. We have the word for. For shows the total cost. This one shows the total cost of the items. So that means you're not required to multiply, you're not required to calculate. They have already given you the cost of all the items. Now, this subtopic or this subtopic called bills is a very important subtopic or rather. In KCP, all the years we receive, or that is they test between an average of 2 questions on bills. So one question is set on preparing bills and getting the balance, and another question involves getting change. So today we are going to concentrate on the questions that want us to get balance. That's what we are going to concentrate on today. So if you look at the KCP analysis for the last 8 years, from 2018 to 2010, you can see last year, that is 2019, they didn't bring a question on balance. What they tested was change. So 2018, question number 44 was testing on balance. 2017, question number 23, tested on balance. That is, they asked how much remained. How much remained, that is the same as getting the balance. 2016, question number 32, they tested on balance. The same with question the year 2015, question number 41, they also tested on balance. Question number, year 2014, there was no question on balance, the same as 2019. They tested only on how to calculate or to get change. 2013, question number 13, they wanted the total cost. That is, we are supposed to calculate, they were supposed to prepare bills and then you give the total cost of whatever was purchased. 2012, the question number 32 was also testing on the total cost. 2011, question number 6, the examiner tested balance. 2010 was in question number 6, the same question was also asking balance. So you can see that in this subtopic, it is very, very important to have mastered how to calculate and how to get balance and how to prepare these bills. So without wasting time, we're going to start by looking at some of the examples here. We see how to calculate and how to get balance and how, first of all, to prepare a bill. So we're going to start by looking at example number 1. Example number 1, the price list of some items in a shop was as follows: soap, 20 shillings per piece; sugar, 45 shillings per kg; bread, 20 shillings per loaf; coffee, 80 shillings per 500 grams. And then we're told that Wanja bought 3 pieces of soap, 2 kg of sugar, 4 loaves of bread, 1 tin of coffee. How much did she receive as balance if she gave 500 shillings note to the shopkeeper? So we have that question with us there. In this question, number 1, we are supposed to prepare a bill. We prepare a bill so that we can get the total amount of money that this person was supposed to pay. And from there, we calculate the balance. And how do we get the balance? For us to get the balance, remember we said that balance is gotten by getting the difference between the total amount of money given out and the total cost of item. So we start by calculating or getting the total cost of those items. So we are told that this person bought 3 pieces of soap, he bought 3 pieces of soap, 2 kgs of sugar, and 4 loaves of bread, 1 tin of coffee, 1 tin of coffee. Yeah, this is what that person bought. That is Wanja. And remember we had said that soap costed 20 shillings per piece, and then sugar costed 45 shillings per kg, and then we had bread. Bread costed 80 shillings per 500 grams. So this 500 grams is the same as a half kgs. So let's prepare her bill. We see how much she paid. So 3 pieces of soap, and a piece of soap costed 20 shillings each. So we are going to take the 3 pieces times the cost of 1 piece. This is soap. So 3 pieces times 20 shillings per piece. Here we get 60 shillings. The other one is 2 kgs of sugar, and 1 kg costed 45 shillings. So it is the number of kgs, 2 kgs, times the cost of 1 kg, which is 45. So it's going to be 2 times 45. We get 90 shillings. Then 4 loaves of bread, and 1 loaf costed 80 shillings. That is per 500 grams. So 1 loaf of bread is 500 grams. So we are going to take the number of loaves, which is 4, times 80. So that is 4 times 80. We get 320. And then let me see the cost of, you have the cost of the coffee. Wait, sorry. Bread costed 20 shillings. This was coffee. Let's correct here. So coffee was 80 shillings per 500 grams. Sorry for that. And then we had bread, which costed 20 shillings per loaf. So here we are going to change this. Bread costed 20 shillings, so it is 4 times 20, we get 80 shillings. Then 1 tin of coffee, a tin costed 80 shillings per 500 grams, and he bought 1. So it is going to be 1 times, that is the number of tins times the cost of 1 tin, which is 80 shillings. So 1 times 80, we get 80. So from there now we add, we get the total cost. So when we add here, we are going to get 0. 9 plus 6, we get 15. 15 plus, this is 16, then 15, we get 16. 1, 31, 310 is the total cost of the items. So the total cost is 310 shillings. Then the question is, how much did she receive as balance if she paid 500 notes to the shopkeeper? So this is the total cost of the items. So we get the balance. To get the balance, we take the amount that she gave 500 minus 310 shillings. So we borrow from here, we get 4. 500 minus 310. 4, 1. 10 minus 1 is 9. 4 minus 3 is 1. So we get the balance was 190 shillings. So that is example 1. We look at example 2. In example 2, we have, you're told, Jerry bought the following items. 3 rolls of paper at 17 shillings per roll. 3/4 of tomatoes at 30 shillings per kgs. 2 kgs packet of rice for 70 shillings. And then 2 bottles of juice at 70 shillings. 2 kgs of sugar for 180 shillings. What balance did she receive if she paid for the items using 500 shillings? So it's the same question. It is similar to the question that you have just done. So the first step is to calculate or to get the total cost of the items. That is to prepare the bill. After you prepare the bill, you get the balance. And to get the balance, you're supposed to take the amount that this person gave the shopkeeper minus the total cost of the items. So let's do that. So we start by preparing the bill. So 3 rolls of paper, 3 rolls of paper at 17 shillings. Then we have 3/4 kgs tomatoes at 30 per kg, and then 2 kg rice for 70 shillings, and then we have 2 bottles of juice at 70 shillings, and 2 kgs sugar for 180 shillings. So we are preparing the bill first. So we look at the first thing, 3 rolls of paper at 17 shillings. This at here means each roll costed 17 shillings. So we take 17 times 3. The number of rolls, there were 3 times the cost of 1 roll. We get 121 carry 2, 51 shillings. Then we have 3/4 kgs of tomato at 30 shillings per kg. So we take the number of kgs bought, it was 3/4 times 30 shillings, the cost of 1. So we simplify here by 2 by 2, 15. 15 times 3 is 45, divide by 2. By 2, 1, by 2, 2, 2. So I get 22 shillings and 50 cents. Then we have 2 kgs of rice for 70 shillings. 4 represents the total cost of the item. So meaning the 2 kgs costed 70 shillings. So we'll come here and write 70 shillings for the 2 kgs of rice. Then we have 2 bottles of juice at 70 shillings. At means the cost of 1 item. So it is 2, the number of bottles, times the cost of 1 bottle. So it is 2 times 70, we get 140 shillings. Here we have 2 kgs sugar for 180. 4 represent the total cost. So the 2 kgs of sugar costed 180. So 2 kgs sugar, 180 shillings. So we add this to get the total. So we can use this because we have the cents. So this is 51 shillings, 0 cents, plus 22 shillings and 50 cents. Then we add to 70 shillings, 0 cents, plus 140 shillings and 0 cents, and then 180 shillings. So we are getting the total. So when we add here, we are going to get 50 cents. 1 plus 2 plus 0, we get 3. 5 plus 2, 7. 7 plus 7, 14. 14 plus 4, 18. 18 plus 8, we get 26. I write 6, we carry 2. 2 plus 1 plus 1, we get 4. So the total cost of the items was 463 463 shillings and 50 cents. So the question is, what balance did she receive if she paid for the items using 50 shillings, 500 shillings? So we get the balance. To get the balance, we take the 500 shillings note that was given out, we subtract the 463 shillings and 50 cents. So here we have 0 cents and we have 50 cents. We borrow a shillings from this side. This was 500. If I borrow a shillings, I'm going to remain with 499 shillings. That shillings is equivalent to 100 cents. So this side I'm going to have 100 cents. 100 cents minus 50 cents, I get 50 cents. 9 minus 3, I get 6. Then 9 minus 6, we get 3. Then 4 minus 4 is 0. So that means the balance is going to be 36 shillings 50 cents. So that was the balance that person got. That is, Jerry got a balance of 36 shillings and 50 cents. Now, with that, we are going to go to look at some of the KCP questions. So they are very similar to what we have done. We look at some of the questions that have been set in the past years, and you're going to start with the question for year 2018, question number 44. Question number 44, 2018 KCP. And the question is, Abdi bought the following items: 5 loaves of bread at 42 shillings, a half kg of meat at 360 per kg, a half kg of margarine for 150 shillings, 4.5 kg of rice at 72 shillings per kg, 2 bars of soap at 105 shillings. What was his balance if he paid using 3 500 shillings note? We go to the question, we calculate, see what you were supposed to do. Or those people who did that KCP 2018, what they were required of them. The first thing is to prepare the bill. So 5 loaves of bread, 5 loaves of bread at 42 shillings, then a half kg of meat at 360 shillings per kg. We have a half kg margarine for 150 shillings, and then we have 4.5 kg of rice at 72 shillings per kg, and then we have 2 bars of soap at 105 shillings. So we start by preparing the bill. This is 105. So to prepare the bill is to get the total cost of the items. 5 loaves of bread at 42 shillings. These arts here represent the cost of one item. So the total number of items of the loaves were 5 multiplied by 42. 5 times 2 is 10. You write 0, you carry 1. 5 times 4, 20, plus 1, 21. 210 shillings. Then we have a half kg of meat at 360 at the cost of 1 kg. That is each item, because I told it is 360 per kg. So we are going to take a half times 360 by 2 1 by 2 1 carry 1 18 because of 16 because of 8 0 we get 180 shillings is the cost of one, that is a half kg of meat. Then we have a half kg of margarine for 150 shillings. 4, that is the cost of the item. So margarine costed 150 shillings. Then we have 4.5 kg of rice at 72 shillings. 4.5, we change this 4.5 to an improper fraction. So you're going to have 4.5, 4 times 2 plus 1. This is 8, 9. We get 9 over 2. So I'm going to use 9 over 2 instead of 4.5. 9 over 2 times 72. We have this at. So by 2, 1, by 2, 36. So I have 36 times 9. 36 times 9. 9 times 6 is 54. I write 4, I carry 5. Then 3 times 9, 27. 27 plus 5. 27 plus 5, I get 32. 324. Then we have 2 bars of soap at 105. 2 times 105. 105 times 2 is, get 10, carry 1, then 2. Get 210. Then from there we add to get the total cost of those items. So this side we add 0 plus 0, 0, 4, and 0. We get 4. We only have one number there. Then 1 plus 8, we get 9. 9 plus 5, we get 14. 14 plus 2, we get 16. 16 plus 1, we get 17. I write 7, we carry 1. 1 plus 2 is 3. 3 plus 1, 4. Plus 1, 5. Plus 3, 8. Plus 2, 10. So the total cost, this is now the total, which is 1,074 shillings. Then the question was, what was his balance if he paid using 3 500 shillings note? It was 3 500 shillings note. So 3 500 shillings note, it is 3 times 500, meaning 1,500. So the person, Wanja, gave 1,500 shillings. We want to calculate the balance. The question wants us to get the balance. To get the balance, you take the amount of money that she gave out, which was 1,500, you less the amount of money or the total cost of the items. That is 1,500 minus 1,074. 1,500 minus 1,074. We less. So this, it is very impossible. So we are going to borrow from this 5. From 5, we get 4. I bring 1 here. I've borrowed 100. I borrow again, remain with 9. 10 minus 4 is 6. Then 9 minus 7, I get 2. 4 minus 0 is 4. 1 minus 1 is 0. So my balance is going to be 426 shillings. So the balance was 426 shillings. So, and that was the answer for that question. Then another question is 2017, KCP 2017, question number 23. And the question reads, Juma was given 2 100 shillings notes to buy the following items: 2 kgs of meat at 400 shillings per kg. 2 kgs of tomatoes at 300 per kg. 1.5 kg of onions at 120 per kg. A half kg of potatoes at 40 shillings per kg. How much money would he remain with after buying the items? So the question is still want us to get the balance, because it is asking how much money would he remain with after buying the items. So just like the way we have done the rest, we start by preparing a bill. So preparing the bill, or a bill, is the first step. So we prepare the bill to see how much he paid. So 2 kgs of meat, 2 kgs of meat at 400 shillings, and then 2 kgs tomatoes at 300 shillings. We have 1.5 kgs of onions at 120 per kgs, and then we have a half kgs potatoes at 40 shillings per kgs. So how much did he pay? So first we get the total. It is the number of kgs for meat times the cost of 1 kg. 2 times 400, we get 800. Then 2 times 300, 2 times 300, we get 600. And then we have 1.5 kgs onions at 120. This 1.5, we change it to an improper fraction for the sake of multiplication. So this is 1.5. You take the whole number times the denominator plus the numerator. This is 2 plus 1, we get 3/2. So 3/2 times 120 by 1 by 2, 60. 3 times 60, we get 180 shillings. Then I have a half kgs potatoes at 40 shillings. It is a half times 40 by 1 by 2, 20. So you come and add 20. So we are adding to get the total. So when I add this side, I get a 0. 8 plus 2, 10. 0, carry 1. 1 plus 8 is 9. 9 plus 6, 15. 15 plus 1, 16. That is 1,600 shillings. That was the total cost. And then we had been told that Juma was given 100 shillings to buy the. Juma was given supposed to be 1,000 shillings note to buy the following items. How much balance or how much remained? So we're going to take the 2 times 1,000, 2 times 1,000 to get the total amount of money that Juma was given. 2 times 1,000, we get 2,000. 2,000 minus 1,600. So we borrow 1. 10 minus 6 is 4. So that means Juma got a balance of 400 shillings. A balance of 400 shillings. So that was the balance that that person received. Then we go to 2016. 2016, question number 32. The question reads, Halima bought the following items from a shop. 2 kgs of sugar at 120 shillings per kg. Then we have 4 packets 4 packets of a half liter milk at 40 shillings. And then we have 1 1/4 kgs cooking fat at 120 shillings per kg. 2 kgs of wheat flour for 210 shillings. 1 1/2 kgs of salt at 24 shillings per kg. She paid for the items using 2 500 shillings notes. How much balance did she receive? So I want to tell myself we are together. So we start by preparing the bill. 2 kgs sugar, 2 kgs of sugar at 120 shillings. And then we have 4 packets. 4 packets of a half liter milk at 40 shillings each. And then we have 1 1/2 kgs cooking fat at 120 shillings each. Packages: 2 kgs wheat flour for 210 shillings. And we have 1 1/2 kgs salt at 24 shillings per kgs. So we are preparing the bill. 2 kgs of sugar at 120 shillings. So it is the number of kgs bought times the cost of 1 kg. That is 2 times 120 shillings. 2 times 120, we get 240 shillings. Then 4 packets of a half liter milk at 40 shillings per packet. So this means that 1 packet of a half liter costed 40 shillings, and he bought 4 packets. So these 4 packets, each packet was a half liter, and this packet of a half liter costed 40 shillings. So it's going to be 4, the number of packets bought, times the cost of 1 packet, which was 40 shillings. 4 times 40, we get 160 shillings. Then we have 1 1/2 kgs cooking fat at 120 shillings. This 1 1/2 is the same as 3 items using 2 500 shillings notes. 2 500 shillings note, 2 500 shillings note. So we get the total amount of money that she used to pay. 2 times 500, we get 1,000. So meaning that the amount of money that she gave out was 1,000. We get the balance. To get the balance, we take the amount of money given minus the total cost of the items, which is 1,000 shillings minus 796 shillings. So 10 minus 6, I get 4. 9 minus 9 is a 0. Then 9 minus 7, we get 2. So the balance was 204 shillings. So and that's what she received as her balance. Oh, we are winding up. We look at one or two more questions. Question number 41 for year 2015. 2015, question number 41. The question reads, the prices of items in a shop were as follows: 1 kg of sugar at 120 shillings, 1 kg of rice at 160 shillings, 1 kg cooking fat at 144 shillings, 1 loaf of bread at 44 shillings. Subira bought 2 kgs of sugar, 1 kg of rice, a half kg of cooking fat, 3 loaves of bread. She gave the shopkeeper 1,000 shillings note. What balance did she get? As usual, we start by preparing the bill. We prepare the bill to get the total cost of the items. After you have gotten the total cost now, we subtract or we minus or we less from the 1,000 shillings note that this person gave the shopkeeper so that we can get the amount of money that remained. So let's go on and start by preparing the bill. So 1 kg of sugar at 120 shillings. 1 kg sugar at 120 shillings. Then 1 kg of rice at 160 shillings. And then we have 1 kg cooking fat at 144 shillings. And then 1 loaf of bread at 44 shillings. So these were the prices in the shop. And then we're told that this person, Subira, bought 2 kg of sugar and then bought a kg of rice. He bought a half kg of cooking fat and also 3 loaves of bread. So we are preparing her bill. If she bought 2 kgs of sugar, 1 kg costed 120. We have at here to mean the cost of a kg. So 2 kgs of sugar times 120, that is the cost of 1 kg. 2 times 120, we get 240 shillings. Then 1 kg of rice, a kg costed 160. So the number of kgs, 1 kg times 160. 1 times 160, we get 160 and 60 shillings. Then 1 kg cooking, a half kg cooking fat, and a kg costed 144. So it is a half what was bought, a half times the cost of a kg, 144. By 2, 1, by 2, 14 because of 7, 4 because of 2, 72. That was the cost of a half kg of cooking fat. Then 3 loaves of bread. A loaf costed 44 shillings. So it is 3, the number of loaves bought, times the cost of 1, which is 44. 4 times 3 is 12. So I write 2, I carry 1. 4 times 3 again is 12 plus 1, 13. 132 and 32 shillings. Then we add to get the total. 2 plus 2 is 4. 4 plus 6, we get 10. 10 plus 7, 17. 17 plus 3, we get 20. 0, carry 2. 2 plus 2 is 4, plus 1, 5, plus 1, 6. We get 604 shillings. Now, this was the total cost of the items. Or this was her bill now. Her bill was 604, and that's what she was supposed to pay. Then we're told that she gave the shopkeeper 1,000 shillings note. What balance did she get? We are calculating the balance, or we are getting her balance. Remember, to get the balance, you take the amount of money that was given out minus her bill, or the total cost. That is 1,000 minus 604 shillings. We borrow from this one 10, we borrow again from here, we get 9. We borrow again, we remain with 9. I bring 1, now I have 10. 10 minus 4, I get 6. 9 minus 0 is 9. Then 9 minus 6 is 3. So the balance that she received was 396 shillings. So and that was the balance, and that was the answer for that year. Yes. So we go to, so I want us to skip and go to year 2012. 2012. Question number 32. Question number 32 for 2012 says or reads, Kyoko bought the following items to donate to a charitable organization. 2 bags of cabbage at 2,500 shillings. 4 bags of potatoes at 2,000 shillings. 20 kgs of cooking oil for 2,000. 100 kgs of sugar at 96 shillings. 50 loaves of bread at 35 shillings. Then he was given a 10% discount for all his purchases. How much did he pay for the item? So in this question, we are required to get the total cost. How much did he pay? So you're only preparing the bill. After he was given the 10% discount, how much did he end up paying? So we start by preparing the bill to get the total amount of money that he was required from whatever he bought. So 2 bags of cabbage. So 2 bags cabbage at 2,500 shillings. Then 4 bags potatoes, shillings, 2,000. 20 kgs of cooking oil for 2,000 shillings. And then we have 1,000 kgs, no, it's 100 kgs of sugar at 96 shillings, and then 50 loaves at 35 shillings. So we get the true amount of money that this person used. 2 bags of cabbage at 2,500. So the number of bags were 2 times the cost of 1 bag was 2,500. 2,500 times 2, we get 5,000 shillings. Then 4 bags potatoes at 2,000. So it is the number of bags times the cost of 1 bag. 4 times 2,000, we get 8,000. Then the 20 kgs of cooking oil costed 2,000. We have 4 to mean the total cost. So the cooking oil costed 2,000 shillings. Then I have 100 kgs of sugar at 96 shillings. So it is going to be the number of kgs bought times the cost of 1 kg. That is 96 times 100, we get 9,600. And then 50 loaves of bread at 35 shillings each. So 50, the number of loaves, times the cost of 1 loaf of bread. So we take 35 times 5, we get 25, carry 2, 15, 17. So we get 1,750 shillings. Then from there we get the total. So we add here, we get a 0. This line we get 5. Then you have 6 plus 7, 13. I write 3, I carry 1. 1 plus 5 is 6. 6 plus 8 is 14. 14 plus 2, 14 plus 2 is 16. 16 plus 9, we get 25. 25 plus 1, 26. We get 26,350. And then we are told that this particular person was given 10% discount for all his purchases. So after this was the total amount of money that he was supposed to pay, but he was given a 10% discount. So we get the 10% discount that he was given from this. And that means if he was given a discount of 10%, it means that he paid at 90%. So first you get the discount. The discount was 10%, so it is 10 over 100 times 26,350. So meaning he was given a discount of 2,635 shillings. So if this was the discount, it means that it was subtracted, or it was less from the total amount that he was supposed to pay. So we take the 26,350, we subtract the discount, and the discount was 2,635. So here we're getting the total paid. The total paid after the discount. The total amount of money that he paid after the discount. So we less. This is, we borrow 1, we remain with 4. 10 minus 5 is 5. Then 4 minus 3, we get 1. 3 minus 6, we borrow 1 from 6, we remain with 5. 13 take away 6 is 7. 5 take away 2, we get 3, and then 2. That means after the discount, he paid 23,715 shillings. That was the amount of money he paid for the items after he was given the discount. Haya. So we have a question here. I want to answer a question. One question here. There's a question here that says, Cargo bought the following items from a shop. 2 kgs tins of cooking fat at 380 shillings, 3 kgs of rice at 84 shillings, 2 kgs packet of unga for 65, 500 milliliters of paraffin at how much did he pay for the items? Higher. So in this question, the question is not complete, but I understand the question is that sign the same as multiply? Came from. All right. So when you're doing bills, when you see this sign, for the sake of Kim and the others, when you see this sign at, when they write at, per, each, the 4 symbols or the 4 signs means you multiply. So I think I've answered the question. So all of them means you multiply because they all show the cost of one item. The cost of one item. So that means you take the total amount of items and you multiply. So this sign, at, per, and each, they all means you multiply. Apart from 4. 4 will always give you the total or the sum, the total cost of the items. So for 4 you don't multiply, but for the rest you multiply. So, and I think I've answered that question. So we have come to the end of our lesson. For your assignment, you can go through the other KCP years, check the questions, try calculate them, and try see what was required of those candidates. So I want to wish you a good day and a blessed stay at home.
I need that magic.
Somebody call 911. Anything for your girl, give me more.
Kwanza tuende lunch. Chapo.
Orosho piga shada kuna giza. Sikinai tujinai siweke story. Kata maji pia shada ligona nasio nikosa msuko si stress. Kama rende kisha basi nipe. Najua ni
You are my mom, big up. Zade, you are a diva, big up. Sis, big up. Shows, mama, big up. Oh yeah, what's your name? Okay, my principal, big up. I'm money me okoka, but they me say no, I know, no, I know. Dancing me shika mashitani, kila tuche kila mtaani. Dancing na leta burudani.
My name is James Mbaro. I'm the managing director at Genovation. Genovation is a software house, is an innovation hub. However, we have currently and of late we have our latest system, which is Jarida. Jarida is a visitor management system. It's also a guest book management system, so where people can sign in that they have come to see you and what they have come to do with it. It's also a service offering system. So for example, those companies that are offering services like lunch, and you need to know who has actually come in for lunch, what time do they come in for lunch, what do they have, and how much you need to compensate the service provider.
Hello students. Hello students and all our viewers. Today on our program Elimu live show, we've prepared for a lesson for the Form 3s in mathematics, and we'll be looking at the topic matrices. Matrices is covered in Form 3, so that is Form 3 with mathematics, and our topic for discussion today is matrices. We'll be discussing about matrices, but specifically in our lesson today we are going to look at the subtopic. We're going to look at the subtopic determinant of a 2 by 2 matrix, and then number 2, we will discuss the inverse of a 2 by 2 matrix. That is what we are discussing in our lesson today. So feel welcomed, students, and let's discuss in details what these two subtopics have to do. Before we discuss the determinant of our 2 by 2 matrix, students, we need to understand one thing, that when talking about a matrix is singular. When there are more than one, we talk of matrices. And a matrix is simply the arrangement of elements in rows and columns. The arrangement of elements in rows and columns. For instance, if I have this as my matrix M, A, B, C, D are what you're calling elements. They are simply the characters of this matrix. And these elements have been arranged in what we call rows and columns. What do we mean by rows? We mean the horizontal arrangement of elements. The horizontal arrangement of elements is what you're calling rows. So these are the rows of the matrix. Elements A, B are in the first row, C, D are in the second row. When we look at the arrangement vertically, and then we talk about what we call columns. So columns is simply the vertical arrangement of elements. That is what we call the columns, and the rows are horizontal. Again, for example, we could have an example of a matrix 8, 6, 2, 7. These are elements. 8, 6, 2, and 7 are elements of the matrix, and they have been arranged in rows and columns. When we're talking of rows, we're talking about the horizontal arrangement, and then column, we are talking about the vertical arrangement. That is what we mean by a matrix. Number 2, students will need also to understand that in a matrix, elements are believed to be in diagonals. So A, B, C, D, we can also explain the arrangement of elements in a matrix to be in diagonal form. What do we mean by diagonal arrangement? This element A and B happen to be in diagonal form. If, for example, illustrate this using a rectangle. A rectangle is a quadrilateral. A quadrilateral meaning it has 4 sides. The endpoints, the vertices of this rectangle, when joined, we obtain what we call a diagonal. Therefore, AC is a diagonal. AC is a diagonal. When we join B and D as well, B and D, again, this is a diagonal. That is in quadrilateral. But for our case in matrices, the element A and D are in the diagonal form. Equally, element B and C are as well in the diagonal form. So how do we refer to these diagonals in a matrices? In matrices, this diagonal, the one running from the left to the right, is what we call the main or the leading diagonal. The main or the leading diagonal. And the other diagonal, this one, is referred to as the other diagonal. So do not ask us what is the name of the other diagonal. It is just referred to as the other diagonal. Therefore, matrices also constitutes of elements arranged in diagonals. And we have two diagonals, the leading diagonal and the other diagonal. Why do we need to know about the diagonals? It is important to know because the understanding of our first element, the determinant of a matrix, is based on how to identify the diagonals of matrices. And we are specific that we are going to do matrices that are of order 2 by 2. Again, students, do you understand what we mean by the order of a matrix? The order of a matrix, we're talking about order of a matrix. Order of a matrix. We are simply looking at the number of rows. The number of rows against the number of columns. The number of rows against the number of columns. Number of rows against the number of columns. You look at the number of rows against the number of columns. So that is what we discuss under the order of a matrix. And therefore, if you have a matrix that has 2 rows and 2 columns, then we refer to that as a matrix of order 2 by 2. And those are the matrices that we will be discussing in our lesson today. That the ones that have 2 rows and 2 columns. For instance, this matrix here, 8, 6, 2, 7. We have 1, 2 rows, 1, 2 columns. That is what we'll be discussing today. So therefore, what is the determinant of a matrix? What do we mean by determinant? Determinant of a matrix. And in this case, our focus is 2 by 2 matrix. Yes, the determinant is simply, this is simply the difference in the product of elements in the leading diagonal and the product of elements in the other diagonal. What we mean by this is that we are going to obtain the product of elements in the leading diagonal and get the product of elements in the other diagonal, then get the difference. Because of the difference, we'll subtract. So this is what we are illustrating. A, B, C, D is our matrix. So what is the elements in the leading diagonal? It is A and D. Therefore, when talking of determinant, we say it is A times D minus B times C. Minus B times C. So A times D, that gives us AD minus BC. Minus BC. That is our determinant for this matrix. The determinant will be AD minus BC. So if you are given a question to determine the determinant of a matrix, then what you shall only need to do is to multiply the elements in the leading diagonal and then multiply the elements in the other diagonal, get the difference. You will be able to obtain the determinant. So let's look at examples, students. Let's look at the explanation we've done using examples. We are told, number one, given that M is negative 2, 1, 6, 5, find the determinant. Find the determinant of M. Find the determinant of M. That our matrix M has the elements negative 2, 1, 6, and 5, and we are required to find the determinant of M. From the explanation, students, how will we work it out? Yes, the elements in the leading diagonal is negative 2 and 5. The other diagonal has 1 and 6. Therefore, our determinant will be negative 2 times 5 minus 6 times 1. Negative 2 times 5 minus 6 times 1. Negative 2 times 5 gives us negative 10 minus 6 times 1 gives us 6. And this gives us negative 16 as our determinant. So the determinant of this matrix is negative 16. Again, why negative 16? That is the difference between the products of elements in the leading diagonal and the product of elements in the other diagonal. We will look at the second example. The second example, we are told to determine the determinants of each of the given matrices below. We determine the determinant of each of the given matrices below. We have our first matrix is 4, negative 6, 3, 10. And then we will look at the second one, where we have 1 over 3, 2 over 5, 6, 1 over 7. Those are the matrices that we have. We have 4, negative 6, 3, 10. And then we have a third, 2 over 5, 6, and 1 over 7. Let's start with the first one, students. What are the elements in the leading diagonal? The leading diagonal has 4 and 10, and the other diagonal has negative 6 and 3. Therefore, to work out the determinant, we will take 4 times 10, the leading diagonal, minus negative 6 times 3, minus negative 6 times 3. 4 times 10 gives us 40, minus 6 times 3 gives us minus 18. And this gives us a total of 58, because minus is plus. So the determinant is 58. Number B, not only will you have matrices given as whole numbers, but we may have matrices that are constituted by elements which are decimals or which are fractions. So in this case, we have fractions. We will work out the same way, that the determinant of this matrix, will be equal to 1 over 3 times 1 over 7. Then we minus 2 over 5 times 6. 1 over 3 by 1 over 7, that is 1 over 21. We minus 2 over 5 by 6 is 12 over 5. So we get this, the LCM of 21 and 5, that is 105. 21 into 105 is 5 times, less 5 into 105 is 21. So 21 multiplied by 12, that is 4, 1, 2, 252. 252 as the product. Then we less this, you get it is negative 247 over 105. We will not give it as negative 247 over 105 because 247 is larger than 105. So as an improper, as a mixed fraction, it will be negative 2, that is 210, then 37 over 105. That is our determinant. So students get to know that not only will we deal with whole numbers, but we will get to a point of dealing with fractions or decimals. Good. That is what students need to understand in the case for the determinant of a 2 by 2 matrix. But to make an extension to that, students need to understand there is something we call a singular matrix. A singular matrix. So what is a singular matrix? What is a singular matrix? Yes, a singular matrix is simply a matrix whose determinant is 0. This is simply a matrix whose determinant is 0. A matrix whose determinant is 0. Meaning, if you work out determinant in the way we've done in our examples, and you obtain the determinant to be 0, then that is what we call a singular matrix. For example, if you have a matrix like 4, 4, and then we have 16, 1, this matrix will be singular. Why will it be singular? If you take the product of elements, the leading diagonal, it will be 4 by 4 minus 1 by 16. So this is 16 less 16 is 0. This matrix becomes singular. But in most cases, questions on singular matrices will not really be as such, but we shall have to determine the values for the unknowns in a matrix. And so once the statement singular matrix is mentioned, students, then be able to know that singular matrices refers to those matrices whose determinant is 0. And in most of the examples we shall be doing, we'll be finding a situation where we have to obtain a quadratic equation and solve the quadratic equation using the methods we've been able to know, and then we obtain the value for the unknown. An example to this effect, number 1, you're told, find the value of x in m equal to x minus 4, 3, 4, 10, given that m is a singular matrix. Given that m is a singular matrix, we determine the value of x in the matrix M, whose elements are x less 4, 3, 4, and 10. And the instructions is that M is a singular matrix. The word singular should not make you run away from this example. We've already explained what singular matrix is. The determinant is 0. Therefore, what you only need to know is how do you get the determinant? You get the products of elements in the leading diagonal minus the products of elements in the other diagonal. So we shall have 10 into x less 4 minus 3 times 4. 3 times 4. So that will mean this is equals to 0 because it's a singular matrix. By expansion, this will be 10x less 40 less 12 is 0. Minus 40 minus 12 is minus 52. Therefore, this is 10x minus 52 is 0. We collect like terms by taking negative 52 to the right side, turns positive. So 10x equal to 52. Then we divide by 10, divide by 10, this cancel out, and x is equals to 5.2. That is the value of x in that matrix. If that is not the case, then we will have such a structure that not told you find the value of the unknown in the matrix A equal to with x 9 3 2x x 9 3 2x given that A is a singular matrix, x is a singular, this is 3, given that x is a singular matrix, we find the value of the unknown, and our known in this case is x. So where do we start, students? We start with the fact that we are talking of singular matrices whose determinant is 0. So what will be our determinant? Our determinant will be equal to 3x times x minus 3 times 9, and this will be equal to 0. 3x times x, 3x squared minus 27 is equals to 0. We take negative to the right side, so 3x squared is equals to 27. Then we divide by 3 by 3. This cancel out, x squared is equals to 9. And so what is our x? Plus or minus the square root of 9, which is 3. So our values of x is either positive 3 or negative 3. That is to imply that you will either have a situation where you have the linear equation, or you'll end up with a quadratic equation. Be able to know how to work it out. At the end of it all, the main thing is based on understanding how to determine the determinant of a matrix, which is simply the product of elements in the leading diagonal minus the products of elements in the other diagonal. And number 2, to understand the concept singular matrices, that they are matrices whose determinant is 0. Good. That is our first area that we were to discuss, discussing determinant of a 2 by 2 matrix. Progressively, once you've been able to understand the concept of determinant of matrices, students need also to understand what we call the inverse of a 2 by 2 matrix. The inverse of a 2 by 2 matrix. When talking about the inverse, we are reversing something, but in terms of matrices, what do you need to do for you to obtain the inverse of a matrix? I'll give you the highlights of the procedure that is undertaken here. Number one, student must be able to know how to get the determinant. So you determine the determinant. You determine the determinant of the matrix. Once you obtain the determinant of the matrix, step number two, you interchange elements in the leading diagonal. You interchange the elements in the leading diagonal, meaning you shift the position from one position to the other, as well do the other case. And then number three, you reverse the signs of elements in the other diagonal. Reversing the signs, if the element had a negative sign, it turns to positive. If it had a positive sign, it turns to negative. That is number three. And then after you've reversed the sign and you've interchanged the elements, you obtain a new matrix. So the last step that you do, you simply multiply 1 over the determinant by the resulting matrix. So those are the 4 steps that students will need to know. That if you are given a question to get the inverse of a matrix, step number 1, be able to obtain the determinant of that matrix. Number 2, you interchange the elements in the leading diagonal. Number 3, you reverse the signs of elements in the other diagonal, and then you multiply 1 over determinant by the resulting matrix. To illustrate this using a general case, students can be able to look at this case here. We have a matrix, for example, A, B, C, D. These are matrix, a general matrix. To follow these steps, we've said the determinant is equals to AD less BC. That is the determinant of that matrix. Number 2, you interchange the elements in the leading diagonal. So you shift. Where there is D, you shift to this position. A, shift to this position. So you'll have D, A. And then change the signs. Negative B, negative C. So this is what you are calling the resulting matrix, of which you now multiply by 1 over AD less BC. You will now be able to obtain the inverse of a 2 by 2 matrix. It's a very simple step that you need to follow to get to the inverse. So students, having explained this, let's look at these examples together and see how practically can you be able to obtain the inverse. Given that A is equals to 1, 4, 9, negative 6, find. And again, students, be very careful. They will not write too much. They will just write A raised to power negative 1. That is the implication that you are supposed to get the inverse. If they don't put it in words, they will write it in simple that way. It means the inverse of A. Therefore, let's start off 1, 4, 9, and negative 6. Our determinant will be equal to 1 times negative 6 minus 9 times 4. So this is negative 6 less 36, negative 42. Then number 2, let's interchange these elements. So we have negative 6, 1, and then change the signs, negative 4, negative 9, and multiply by 1 over 42. This is negative. So this will give us 1 over 7, 2 over 21, we have 9 over 42, then negative 1 over 42. If someone is lost, students, this is what we've done. Negative 1 over 42 times 6 gives us positive 6 over 42. And 6 can be divided, 42 can be divided by 6 to have 7. So that's why we have 1 over 7. 1 over 42 times negative 4 will have positive 4 over 42. 2 is 2, 2 is 21. That's why we have 2 over 21. Then negative 1 over 42 times negative 9 is positive 9 over 42. Again, that can be simplified because 3 can divide 3. 3 here is 1 into 12, 4. So that should be 3 over 14. To simplify, it should be 3 over 14. And then 1 over 42 times 1, that gives us negative 1 over 42. And this is the inverse of our matrix. So we look at the inverse in that way. Either they will write the word inverse or they will write a power negative 1, be able to obtain that. And now, students, I want to bring in a broader question that encompasses various aspects that we've been able to look at. And this will be the case that given that X is a matrix 2, negative 1, 4, 9, Y is the matrix 1, 2, 10, negative 8. Find A, Y such that, so this is Z, sorry, Z such that Z is equals to 2X plus Y. Part B will now have to get the determinant of Z, and C the inverse of Z. Those are 3 matrices, and I've put it that way so that we're able now to move in this line. How do we determine the determinant of unknown matrix? By first following up the steps that we've been given from the given matrices. So where do we start, students? We have X 2, 4, negative 1, 9, and we have Y 1, 10, 2, negative 8. The instruction is that Z is 2X plus Y. So we'll start from that point and say our Z will be equal to 2 into X. X is 2, negative 1, 4, 9, plus Y, which is 1, 2, 10, negative 8. Now we expand. Multiply what is outside the bracket by every element in the bracket. And so that will be 2 by 2 is 4. 2 by negative 1 is negative 2. 2 by 4 is 8. 2 by 9 is 18. Then we add 1, 2, 10, and negative 8. We add elements in their respective position from each matrix, meaning first element in the first matrix, first element in the second matrix. So 4 plus 1 is 5. Negative 2 plus 2 is 0. 8 plus 10 is 18, and 18 plus minus 8 is 10. That is our matrix Z. Therefore, in the question, anywhere they are mentioning matrix Z, the matrix Z is 5, 0, 18, 10. So we need to use this matrix Z to work out part B, where the instructions to get the determinant of Z, and part C, the inverse of Z. So what do we do in this case? Very simple. Take our matrix for part B. Z is 5, 10, 0, 8, 10. we get the determinant, and the determinant is equals to 5 times 10. We minus 10 times 0. 5 times 10 gives us 50 less 0. So the determinant is 50. Our determinant is 50. What about the inverse? Inverse of z, which will be written as z power negative 1. We've said in the inverse, get the determinant, so we already have the determinant. We reverse the elements, so we shall have 10 taking the position of 5 and 5 taking the position of 10, and then have this change in signs. So this will be 0, negative 10. And then we multiply by 1 over 50, which is our determinant. We expand, therefore. 1 over 50 by 10 gives us 1 over 5. 1 over 50 by 0 is 0. 1 over 50 by negative 10, negative 1 over 5. And 1 over 5 by 5 is 1 over 10. That is our inverse. So that is how we obtain the inverse of a 2 by 2 matrix, for this case, for the matrix Z and A that we've worked out with. Again, students, I will take you back to where we mentioned the word singular matrix and add something to that statement. We've said singular matrix. When you're explaining singular matrix after discussing the concept of determinant, we purely say that a singular matrix is a matrix whose determinant is 0. After you've now gone through the inverse, we add in a statement that singular matrices have no inverse. So if you are told a statement that you find the value of the unknown in a matrix that has no inverse, then know that is a singular matrix. So we are adding something here that it's a matrix. It is a matrix that has no inverse. And remember, the determinant is 0. That is what we call a singular matrix. So given that statement, we can therefore work out number 3. Given that statement, we can work out number 3. And this is our question 3. Find the value of A such that the given matrix is this given matrix such that the given matrix has no inverse. Given that this given matrix has no inverse. So we have 2A plus 4, and then we have 8, 3, and negative 2. We find the value of A such that the given matrix has no inverse. Again, I'm repeating, they might not mention that it's a singular matrix, but rather say that matrix is or has no inverse. Then remember, any matrix that has no inverse is a singular matrix. And therefore, if it's a singular matrix, the determinant is equals to 0. So we simply work out with figures, and we work it out this way. What are the elements in the leading diagonal? We have 2A plus 4 and negative 2. The elements in the other diagonal is 3 and 8. Therefore, our determinant, as explained before, will be negative 2 into 2A plus 4 minus 3 times 8. And because this matrix has no inverse, then this determinant will be equal to 0. So we expand, this will be negative 4A, negative 8 minus 24 is equals to 0. Minus 8 minus 24, that is minus 32. Therefore, minus 4A minus 32 is 0. Take this to the right side. Minus 4a is equals to 32. Then divide by negative 4. Divide by negative 4. This cancel out. And a is equals to negative 8. So it means the value of a in that matrix, for that matrix to be singular or to have no inverse, is negative 8. That is our question 3. And our last example on this case, our last example is number 4. The following matrices have no inverse. Find the value of the unknowns. Find the values of the unknowns. Find the values of the unknowns. The first matrix that we are having is a matrix X plus 2. Then we have 5, 2. And then we have this as 7. That is the first matrix. And the matrix X plus 2, 5, 2, 7 has no inverse. Again, has no inverse is what guides us. This statement, it has no inverse. It means that this matrix has a determinant of 0. So students, let's do the multiplication. 7 into x plus 2 minus 10 is equals to 0. Minus 10 is equals to 0. So this gives us 7x plus 14 minus 10 is equals to 0. 14 minus 10 is 4 is equals to 0. And then take this to the right side. 7x is equals to minus 4 over 7 over 7. This cancels, so x is equals to minus 4 over 7. And if you replace minus 4 over 7, you'll try to work it out, you'll still find the determinant of this matrix to be 0. So that is the first case where we are determining the value of x for which this matrix is equals to, has a determinant of 0. Let's look at the second one. Now we have the case for y plus 2. Let's use negative y minus 4, and then we have 3 with negative 2, and then we have 2 at this point. So we get the value for y. The determinant again, students, will be leading diagonal 2 into y minus 4, then minus 2 times 3, and equate that one to 0. By expansion, this is 2y, 2 by 4, it's 8, minus 2 by 3, minus 6, and equate this to 0. Minus is plus, so we have minus 8 plus 6, that's minus 2. Therefore, 2y minus 2 is 0. Take minus 2 to the right side. 2y will be equal to 2. Then divide by 2 by 2. You get your y is equals to 1. So the value of y in that matrix is 1. So that the value, the determinant becomes 0. So that is the case for inverse of a matrix, where they have mentioned the aspect of no inverse to imply they are singular matrices. The last case, last example, before we can conclude our lesson, you are told to find the inverse of the matrix. Find the inverse of the matrix. 8, negative 4, negative 7, 3. You find the inverse of the matrix 8, negative 7, 3, negative 4. The students should now be able to tell the elements in the leading diagonal, it's 8 and negative 4. The other diagonal is 3 and negative 7. Therefore, our determinant will be equal to 8 times negative 4 minus 3 times negative 7. Minus 3 times negative 7. 8 times negative 4, we have this as negative 32 minus 3 times negative 7, negative 21. Negative, negative, that turns to positive, and therefore this is negative 31. So this is negative 11, negative 11. Then we get to the inverse. With the inverse, we are saying we interchange the elements in the leading diagonal. So negative 4 takes that position. 8 takes what is negative 4. Change the signs. So that is 7, negative 3. And then multiply by negative 1 over 11, or negative 1 over the determinant. By expansion, negative 1 over 11 times negative 4 gives us 4 over 11. Negative 1 over 11 times 7 gives us negative 7 over 11. Negative 1 over 11 times negative 3 gives us 3 over 11. And negative 1 over 11 times 8 gives us negative 8 over 11. This is the inverse of our matrix. That is the inverse of our matrix. Therefore, students, we have discussed 3 items in our lesson. We've discussed the determinant of a matrix, the inverse of a matrix, and we've joined those two using what we call a singular matrix. And we've said a singular matrix, a matrix whose determinant is 0 or it has no inverse. So this is your practice questions in what we've been able to discuss in our lesson today. So this is a practice of study questions. Number 1, you're told to find the determinant. Find the determinant of the matrix T, which is 1, 8, negative 2, 7. Q, the matrix Q has negative 8, negative 5, 10, negative 12. You find the determinant of those two matrices. Number 2, this is what you'll attempt. Given that M is equals to 2, 9, negative 1, 4. N is equals to negative 1, negative 7, 3, negative 6. Find part A. Find part A, the matrix P such that P is equals to 3n plus 2m. 3n plus 2m. Part B, you find the inverse of P. You find the inverse of P. And number 3, students, this will be your work again. You are told given that Q is a matrix 7, 7, 8, 7, 2x plus 4. Given that the matrix Q is singular, find the value of x. Find the value of x. Find the value of x. And lastly, number 4, find the value of m for which the matrix m less 7, 8, 10, negative 4 has no inverse, for which the matrix M less 7, 8, 10, negative 4 has no inverse. Those are your practice questions that you'll be able to look at after we are done with our lesson. So in brief, we've been able to look at 3 items again: determinant, inverse, and then singular matrices. So that is all for our lesson today. We stop there until we meet in our next lesson. I've been your teacher, Mr. Ndenga Elfas. Goodbye.